So let's summarize that last lecture. So we had these two theorems, right? The first one says that when we sample from a normal population, then X bar, which is the sampling distribution of the mean, that's also going to follow a normal distribution, regardless of sample size. And when you guys were watching that video simulation, she showed you that when she sampled from a normal distribution, whether the samples were size 2, size 5, or size 50, X bar followed a normal distribution. The other theorem says that when sampling from a non-normal population, X bar is approximately normal only if N is bigger than 30. So as long as we sample from a normal population, it doesn't matter about sample size. X bar is going to be normal. But if we sample from a non-normal population, X bar is only going to be approximately normal if N is bigger than 30. Otherwise, we say that the shape of X bar is unknown. So let's go do a couple of examples to illustrate this. We'll kind of put these into action. So let's look at number 6. So we're up to example 6 from the chapter 8 worksheet. So the last thing that we covered were these two theorems. So for chapter 6, for example 6, it says for each of the following parts, you're given the approximate population shape, the population mean, the population standard deviation, and we're asked to form a sampling distribution of the mean X bar by selecting all possible random samples of size n. So we're being asked to determine three things. What's the approximate shape, normal or unknown, for the sampling distribution of the mean? What's the mean of the sampling distribution of the mean, which is mu sub X bar, and what's the standard error of the mean, which is sigma sub X bar. So there's 4 different examples here. No, actually, there's 4. A, B, C, D. We're not going to cover E and F. Okay, so let's look at A, B, C, D. So we have a population in A that's uniform in shape. So imagine this was a histogram and the height of all the bars was exactly the same. So we have this uniform distribution. The mean of this distribution is 160 and the standard deviation is 8. Now imagine we're going to take samples of size 64 from this uniform distribution, and we're going to calculate X bar from every single sample of size 64. What would the shape of X bar be? What would the mean of all the X bars be? And what would the standard deviation of all the X bars be? So that's what we're doing. So we're sampling from a non-normal distribution, right? This is not a normal distribution in A, it's uniform. So we can't assume that X bar is going to be normal. So what do we have to do? We have to look at sample size. And remember what central limit theorem says. We can only apply the central limit theorem if N is greater than 30. Since it is in this case, my sample size is 64, we can say that X bar is approximately normal. So the shape of X bar is approximately normal. Mu sub X bar is equal to mu, which in this case is 160. And sigma sub X bar is equal to sigma divided by the square root of n, which in this case is 8 divided by the square root of 64. And 8 divided by 8 is equal to 1. So that would be the standard error, 1. So let's look at part B. So what if we were to sample from another non-normal distribution, this is triangular, that has a mean of 16. So this population has a mean of 16, a standard deviation of 3. Imagine we're going to take samples of size 81. What is the shape of X bar going to look like? What is mu sub X bar going to be equal to? And what is sigma sub X bar going to be equal to? So same 3 things we're calculating for part B. So since we're sampling from a non-normal distribution, we can't assume that X bar is going to be normal. We have to look at sample size. Since the sample size is greater than 30, we can apply the central limit theorem and say that X bar is approximately normal. Again, since n is greater than 30. Mu sub X bar is equal to mu, which in this case is 16. And sigma sub X bar is equal to sigma divided by the square root of n, where sigma is 3. N is 81, so we're going to divide by the square root of 81. And now we have to take 3 and divide that by the square root of 81, and that's going to be 1/3, or about 0.33. Let's look at part C. So part C says, this is any shape. We're going to sample from this shape distribution, which doesn't really have a name, but it's not normal. It has a mean of 4,000, has a standard deviation of 200, and we're going to take samples of size 25. So we want to determine the shape, the mean, the standard deviation of X bar. So since we're sampling from a non-normal distribution, we can't assume that X bar is normal. We have to look at sample size. And remember, the only way that we can assume X bar is approximately normal if we're sampling from a non-normal distribution is if n is big enough, bigger than 30. But in this case, n is not bigger than 30. So we're going to say that the shape of X bar, so the shape of X bar is unknown. Mu sub X bar is going to be equal to mu, which is 4,000. And then we could calculate sigma sub X bar, which we know is sigma divided by the square root of n. So we're going to take 200, divide that by the square root of 25. So we're going to take 200 divided by 5, and we're going to get 40. So even though the shape of X bar is unknown, since we couldn't apply the central limit theorem, we could still calculate the mean and the standard error of the sampling distribution of the mean. Let's do one more. Suppose we're going to sample from a normal distribution that has a mean of 1,200 and a standard deviation of 400. We're going to take samples of size 16. So what's the shape of X bar? What's the mean of all the X bars? What's the standard error of all the X bars? Same 3 things that we're calculating for each one of these. Now, since we're sampling from a normal distribution, X bar is normal automatically. It does not matter about sample size. Remember what we said in the summary. So let me just go back to the whiteboard for a minute. When sampling from a normal population, X bar will also follow a normal distribution, regardless of sample size. It doesn't matter about sample size. So as long as we're sampling from a normal distribution, X bar is going to be normal. Mu sub X bar in this case is equal to mu, which is 1,200. And sigma sub X bar is going to be sigma, which is 400, divided by the square root of n. So that's going to be 400 divided by 4, which is 100. So in the next lesson, we'll continue doing examples similar to this one, where we have to identify the shape of the sampling distribution of the mean and the standard error.